One of the first things you should learn about when learning basic organic chemistry is what is an organic compound. At the grocery store, an organic compound is everything because most things you eat are carbon-based. However, in chemistry, an organic compound is specifically something that is carbon-based. A carbon-based compound has some prefixes that can help you determine how many carbon atoms are in the molecule. The prefix meth means one carbon. The formula for methane, for example, is CH4. The prefix eth means two carbons, so the formula for ethane is C2H6. The prefix prop means three carbons, so propane, which is a fuel that many people have heard of, is C3H8 for the formula. There are three carbons and 8 hydrogens. The prefix bute means four carbons, so butane, which is found in lighters, is C4H10. Some additional prefixes are listed in the table. If you have been paying attention, then you may have noticed that they all end in ane. A compound that ends in ane is something that we call an alkane. An alkane is a hydrocarbon that is composed of hydrogen and carbon that are singly bonded. All of the bonds between the carbon and this butane are singly bonded. Hexane, heptane, and octane would also contain single bonds. The formula for a linear alkane that is not in a ring is CnH2n plus 2, where n is the number of carbons, and the number of hydrogens can be determined by doubling the number of carbons and adding 2. The formula for butane, methane, and every other chain or branched hydrocarbon that is all single bonds, or an alkane, is double the number of carbons and then add 2, and that's how many hydrogens there are. In answering the question, what is the formula for octane? Oct is the prefix for 8, which means there are 8 carbons. So it is C8. To determine the number of hydrogens, double 8 to 16 and then add 2, which means that will be 18 hydrogens in octane. Non is the prefix for 9, that is not in our table. Nonane would be C9, double it to 18, add 2, and it would be H20. And then decane, dec means 10, so 10 carbons would be C10, H22. Keep in mind that this formula is valid for linear or branched alkanes where there is not a ring. This schematic demonstrates pentane, which is C5H12 in accordance to the alkane formula, and this is a linear or branched alkane. Cyclopentane, with cyclo meaning ring, would be a slightly different formula. It would be CnH2n. In forming the bond from one carbon to the next in a ring, 2 hydrogens are removed from the formula, like this. Thus, the formula for cyclopentane would be C5, still because it's pentane, but the cyclo lets us know that there are 2 fewer hydrogens, which would mean it is C5H10. At the top, I added that an alkane is CnH2n plus 2 for a branched alkane, or if it is a ring, it is CnH2n. At any rate, we consider these compounds to be saturated because there are no double bonds. A quick look at saturated versus unsaturated. Take a look at these two different compounds. The one on the left is called butane. In accordance with it being an alkane, it has all single bonds and fits the formula for a branched or linear non-cyclic alkane of CnH2n plus 2, giving us a formula for butane of C4H10. We would call this compound saturated because it contains only single bonds. In a different corner would be butene, specifically 2-butene, and the formula for this is C4H8, which seems to fit the same formula for a cycloalkane. However, we would not call this compound an alkane. We call this type of compound, a compound that contains a double bond, an alkene, hence the ending butene. So this is an alkane, and on the right we have an alkene. The ending "ene" means double bond. The formula for a branched alkene is actually the same as that for a cycloalkane, which is CnH2n. The most important takeaway for this is that saturated compounds have no double bonds and no triple bonds. An unsaturated compound has at least one single or double bond in that carbon chain. Although you don't need to know this for most general chem classes, the 2 in front of the 2-butene denotes that the double bond is on the second carbon. It is between the second carbon and the third carbon, and the 2 denotes that it is starting with the second carbon and then goes to the next, which would be the third carbon. When there are only single bonds present, we call that an alkane. When there is a double bond present, that is called an alkene. An alkyne is the name of a compound that is a hydrocarbon with a triple bond. Propane, we know that pro means 3 carbons, and ane means, well, really prop means 3 carbons, and ane tells us that they are singly bonded together. Under this understanding, we can know that an alkane is going to be CnH2n plus 2 for the formula, if it's not cyclo. And since it doesn't say cyclopropane, we can follow the normal formula for an alkane. The formula will be C3, double 3 to 6, add 2, and it's 8. If you were to draw it, you connect all of your carbons using a single bond, complete the octet for each carbon, and that is where the hydrogens will go. Notice the difference in propane versus what I just drew, which is propene, that has a double bond and therefore loses 2 hydrogens. The suffix "-ine" means that there's a triple bond, and the formula is changed once again to C3H4. We double 3 to 6 minus 2, and we get 4, which is in accordance to the formula for propyne. Alkanes are saturated, and alkenes and alkynes are unsaturated due to the double and triple bonds. The next video will cover what exactly functional groups are and the main functional groups that you can look for in molecules.